So in order to detect both these kind of vulnerabilities, we need to implement a comprehensive security strategy as part of our DevSecOps approach. So for internal source code, you need to eliminate vulnerabilities by eliminating them directly in the source code. And if you use a DevSecOps approach where you're checking your code every day for these security vulnerabilities, then you can quickly find them and the cost of remediation is low. All right, so let's dive into DevSecOps for source code. So GrammaTech, as I mentioned earlier, has been involved in static application security testing for a long time with its CodeSonar platform. And for those of you that aren't familiar with CodeSonar, it is a multi-language static analysis tool with abstract execution technology. We've got support for the most popular programming languages and hardware platforms. And what CodeSonar provides is not just warning or defect finding, but it provides a full management interface so you can actually suppress warnings and manage them in a process-driven way with our CodeSonar hub. We've got a friendly interface for developers where we don't just report a warning on a line, but rather we give clear explanations and path information of how a defect actually comes to pass, what conditions, if statements have to be true or false, and we provide visualization tools for the entire program to make it easier to track down those bugs and what other code they might be affecting. The tool can be integrated with popular CI and CD tools such as GitLab and Jenkins. So obviously that's our focus here today on DevSecOps, is integrating static application security testing into your CI/CD workflow. And of course, CodeSonar can identify many of your common security vulnerabilities. So these would be zero-day vulnerabilities in your own static code, in your own source code, pardon me, that such as tainted injection or buffer overflow or command line injection, those kind of very severe security vulnerabilities. So when we talk about DevSecOps for source code, again, referring back to our earlier diagram, we're talking about integrating a static application security testing tool into your development and test cycle, so that every time you make a code change and you run it through your CI/CD pipeline, you've got analysis taking place and new security vulnerabilities are being reported. So here's an example with GitLab. So this is a typical GitLab workflow. We've got on the left a developer who creates a new branch, is pushing code changes into that branch, and then you've got this continuous integration box where the automated build and test is happening. And this is where our CodeSonar workflow is into this automated build and test cycle. So we're going to zoom in here and see that in the CI workflow, you'll integrate a CodeSonar runner as part of your GitLab pipeline merge request. So every time you try to merge code, we're going to run whatever tests you're running, as well as a selection of static application security testing tests via CodeSonar to reveal any security vulnerabilities. So what this achieves is a shift left from that quality assurance aspect of static code analysis and testing into the development phase. And this is going to help us detect our zero-day vulnerabilities every day in our development flow. So if we take a look here, these are screenshots from the GitLab integration. So on the left, you'll see CodeSonar will provide a summary of what kind of warning classes have been detected. So each of these classes corresponds to security vulnerabilities, along with a summary of the high, medium, and low vulnerabilities that you have in the top left. Then in the middle screen here, we're showing a vulnerability report. So this is GitLab's integrated vulnerability report, which is presenting the data from CodeSonar. You've got the classification of vulnerabilities along with a detailed list of the detected vulnerabilities. You can work with these directly inside of GitLab. So developers don't have to leave the GitLab interface if they don't need to. They can just view a defect. You can see here detailed information from CodeSonar is being provided on a specific issue such as this resource leak. And you've got everything you need to triage a defect, go back to your source code, take a look at it, and then you can decide who to assign it to. You can create a GitLab task directly from the GitLab interface to assign this to a developer. So typically this might be a peer review or a security reviewer who would be doing this work. And you can see at the bottom here, if you want to dismiss the vulnerability or create an issue, that's how you can do it. So it's right inside of GitLab. But as I mentioned earlier, CodeSonar does provide some extremely detailed defect information, which if you're having trouble, for example, understanding what conditions you might need to reproduce this defect or understand under what conditions it might occur, you can just click in GitLab on the issue screen and it will bring you into the CodeSonar hub, which will provide the full warning class information on a vulnerability. So you can see in the top half, you've got the summary of the warning along with all of the mappings to the various CWE identifiers and CertC identifiers. And then in the bottom half, it's got the control flow information indicating if an if statement needs to be true or false, for example, in order for this warning to occur. So you've got the full power and full information of CodeSonar, but you've also got the workflow of GitLab, which is how your developers are going to be used to working. So CodeSonar also offers its own built-in reports in the event that you want to use these, for example, from a management perspective. So every week you might present these at a weekly meeting to understand if you're introducing more defects into the code or if they're being reduced. And also you might use these for artifacts, for example, if you're doing any kind of compliance activity in the medical device space, for example, or automotive space, where you want to prove that your code not only is of high quality, but also very secure. You can use these artifacts to show that you have no defects of a certain kind present in your code. So the summary of the DevSecOps for source code here is that we're moving the security of source code into the development cycle. Early detection of these vulnerabilities reduces the cost of remediation, the risk of missed release dates, and that security is not just a quality assurance activity, but it's an everyday activity.